In this session, we'll discuss about the cantilever method of analysis of multi-story frames. The cantilever method of analysis is more approximate for all shutters, that is, for a height greater than its width. The main assumptions here are the point of counterflexure occurs at the middle of the member of the frame. Direct stress, that means point of counterflexure will exert the middle of the column or beam, median of the member. Direct stress in the column are proportional to the distance from the centroidal vertical axis of the frame. Sigma is directly proportional to x. So as x increases, means distance of from centroidal axis increases, stress will also increase. Sigma is directly proportional to x. Therefore, we can write sigma 1 by x1 equal to sigma 2 by x2 equal to sigma 3 by x3 equal to sigma 4 by x4. So the main steps involved are first finding the centroidal axis, then find out the axial force in the column, calculate the shear force in the end beams, calculate moment in the end beam, and calculate the moments at the end of the column. So let us see a problem. Analyze the frame by cantilever method, assuming all the columns having same area of cross section. So first step is to find the centroidal axis distance. That is, if it is centroidal axis, if it is from a reference column. Let us take AEI as reference column, and from the reference column, the centroidal axis is x bar. We need to find this x bar, and also x1, x2, x3, x4. What is it? What are these? X1 is distance from the first column AEI to centroidal axis. Then x2 is the distance from centroidal axis to second long column BFI. Next CGK and the distance between CGK and the centroidal axis x3. Next distance between centroidal axis and the last column, this one DHL, it is x4. We need to find this. So how to find? The formula for centroid is x bar equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 plus divided by a1 plus a2 plus a3 plus a4. Here it is given as a same area of cross section. Therefore a1 equal to a2 equal to a3 equal to a4 equal to a. So now what is a1 x1? X1 means here in the formula it is the distance from reference column to the same column, that is 0. Next, here x2 means the distance between first column and second column, that is 7. Next, the distance between the first column and third column, that is x3. In this formula, in centroid formula, x3 is this one, the total distance. In the centroid formula, x4 is the total distance. So a4 into total distance. So from here we will get considering this one a. So we will get x bar equal to this one. So x bar equal to x1. So x bar x1 is same. Then x2 equal to, from figure, x bar minus 7, that is 8.125 minus 7. x3 10.5 minus 10.5 minus x bar, that is 10.5 minus x bar. Similarly x4 equal to 15 minus x bar. Next, step 2, calculating the axial force in the column. So in story 1 and story 2 we need to calculate the axial forces. So we know this this formula in cantilever method, sigma 1 by x1 equal to sigma 2 by x2 sigma is 3 by x3. So sigma means stress. Stress is load by area. If V is a load, force by area, we can write V1 by A, V2 by A, V2. So if A get cancelled, we will have V1 by x1 equal to V2 by x2, V3 by x3, V4. What is this V1, V2, V3, V4? These are the axial forces in the column V1, V2, V3, V4. And in story 2, the axial forces are V1 dash, V2 dash, V3 dash, V4 dash. The another assumption in this cantilever method is, to the left side of the centroidal axis, we need to take the axial force downwards. See, V1 is downwards, V2 is downwards, V1 dash is downwards, V2 dash is downwards. To the right side of the centroidal axis, we need to take the axial forces upwards. See, all these four are upwards. That is also an important thing to remember. So from here we will get V2 equal to V1 x2 by x1, V3 equal to V1 x3 by x1, V4 equal to V1 x4 by x1. Now we will apply sigma m about n equal to 0. What is n? N is the point of counterflexure for this column. If it is n, it is exactly center. Let us apply sigma moment about n equal to 0 for story 1. For story 1 means we need to consider force into perpendicular distance, 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 force into perpendicular distance. We need not to consider this thing, because it is for story 1 only. Therefore here if you apply sigma m n equal to 0, we will get this equation. So here in terms of v1, v2, v3, we need to substitute these things. So everything we'll get in terms of v1. So we can find v1 from here. v1 value is 63.855 kN. Substituting v1 value here, we will get V2, V3, V4. So in step 2 we have found this V1, V2, V3, V4, and then we need to find this one also. So for this we need to consider the upper part, story 2. So upper part, story 2, V1 dash, V2 dash. Here one more thing is external forces are also to be considered. 120, 180 is also considered here. So here, so in story 1 we need to consider both the external forces. For story 2 only one external force is enough, 120, and V1 dash, V2 dash, V3 dash. So applying sigma m about m is center of this column. So we can find the V1 dash, V2. We will get an expression in terms of V1 dash, V2 dash, V3 dash, V4 dash. So substituting V2 dash, V3 dash, V4 dash in terms of V1 dash like this. So we will get in terms of V1 dash, and then we can find V1 dash value. Substituting in those values, in these values we can find like this, V2, V3, V4 dash also we can find. Check is sigma V dash equal to sigma upwards equal to sigma V downwards. So V1 dash plus V2 dash should be equal to V3 dash plus V1 dash plus V2 dash should be equal to V3 dash plus V4 dash. So it is getting same. So it is correct. Calculation of shear force in the end beam. So story 2. First we are taking story 2 here. Here there are some sign conventions, like suppose it is a joint E. So the forces entering the joint is taken as positive. The forces leaving the joint are taken as negative. Here, for example, it is positive, it is negative, it is negative. So first let us start from joint E. So at joint E, at joint E, shear force at joint E is V1 dash minus V1. See here. So shear force at joint E is V1 dash is entering, so plus V1 dash, V1 is leaving, so minus V1. Therefore we will get it as V1 dash, V1 already we have found, therefore we will get 49.685, that is minus 49.685, we have 45.59, sorry, minus 45.59 we have got. Next, at joint F, so this 45.59 is coming from left side, from E it is coming. So as it is, we need to take the value minus 45.59, next plus V2 dash minus V2, because V2 dash is entering, V2 is leaving. Then we will get FF, shear force at F. Then at joint G, FG equal to minus of 53.64. See here, minus of 53.64 at joint G. It is coming from left side. Then minus V3 dash plus V3. So in the same way, H, F shear force at H at joint H equal to minus 40.23, which is coming from left side, minus V4 dash plus V4. Next, at joint A, shear force at A equal to minus V1 dash. That's it. Next, shear force at joint B equal to minus 13.03 minus V2 dash. Minus 13.03 is from left side for B joint, left side, and V2 dash, minus V2 dash. Next, at joint C, minus 15.33 plus 3.83. At joint C, minus 15.33 plus V3 dash. Next, at D, minus 11.49 plus 11.49, V4 dash is 11.49. So in this way, the step 3 completes. We can find all the shear forces. Next, step 4, calculating the moments of end beams. That means story to MAB equal to, in each beam we need to calculate the moments. Moment formula is moment equal to force into perpendicular distance. So perpendicular distance is L by 2 here. So in each member MAB, MBC, MCD, MEF, FG, MGH, we need to calculate force into L by 2, that particular length. In that way we can calculate all these moments. Yes, in this way. Next, step 5, calculation of moments at end columns. Means at end columns we need to find. That means in MAE we need to calculate MBF, MCG, MDH, MEI, MFJ, MGK, MHL. All these we need to calculate. So MAB, first of all, MAB is nothing but equal to MAB. So MAB equal to MAE. So MAB done. Next, here we need to find this one. So this plus this is equal to this one, like that. Next this one, this plus this equal to this one. Next this one is equal to this one. Next we need for this one, so this plus this equal to this one. Now next we need this one, so this plus this equal to this plus this. From there we can find this one. Here this plus this equal to this plus this, we can find this one. Next we need to find this one. This plus this is equal to this one. So like that we can find all the moments also in the columns. There ends your problem. The final step is you can draw the bending moment diagram. For beams it is like this for all the beams, and you can write the values there. MAB values, MAB value you can write like this. MBC values you can write like this. MCD you can write here and here, here and here, here and here. The same values will come. Next for columns, the bending moment diagram will be like this, like this, like this, like this, like this. Here again beam, so like this. So all these values also you can represent here. It is very simple. Yes, thank you so much.